Hello dear students, welcome once again to my channel Maths in Minutes with Priya. Today's session is Factorization Part 3. I hope you already watched Part 1 and Part 2 of Factorization, and also before that I had posted divisibility criteria videos. I hope you watched that also. We learned many divisibility tests, and also we learned concept of factorization. We are going to use that concept today, concept of factorization. But today you on your own are going to create some divisibility test, and you will be very much excited how simple this trick is. So let us first understand this trick. Trick is factorize a number in such a way that there is no common factor between the factors. Confused? Don't be so confused. I know this mathematical language is a bit difficult to understand. It always confuses us. So what I'm going to do, I'm going to first elaborate this trick and then we'll again come to this language and then you will understand it better. Okay? So let's start with simple number 12. With 12, if I ask you to factorize it, how do you factorize? You start with 1. 12 can be factorized as 1 into 12, as 2 into 6, as 3 into 4. And if I go further, it will be 4 into 3, 6 into 2, 12 into 1. So these factors will repeat in reverse order. So these many factors are there of 12. Now for this trick, I am going to ignore this one. See, for every number, 1 and the number itself are always the factor. So let us ignore them. Consider these two. 2 into 6 same as 6 into 2. 3 into 4 same as 4 into 3. So let us consider these two ways of factorization. Now the trick says factorize a number in such a way that there is no common factor between the factors. If I talk about 2 and 6, is there any common factor between them? Yes, 2 and 6 have common factor 2 because 2 itself is a factor of 6. Isn't it? 2 3s are 6. So I am not going to consider this. It doesn't satisfy this criteria. Now 3 and 4. 3 into 4 is 12. 3 and 4. Do they have any common factor between them? No. So I am going to consider this pair. Now we are coming to the most important part. When I say 12 is equal to 3 multiplied by 4 and 3 and 4 do not have any common factor, then a number which is divisible by 3 and 4 is also divisible by 12. So what happened just now? You discovered divisibility test for 12. A number which is divisible by 3 and 4 is also divisible by 12. So if we want to find out a given number, if it is divisible by 12, what you will do? You will apply criteria. You will apply tests for 3 and 4. If it satisfies, then it is divisible by 12. Here, vice versa is also true. That means if a number is divisible by 12, you already know a certain number is divisible by 12, then be sure that it will be also divisible by 3 and 4. That means divisibility by 3 and 4 implies divisibility by 12, and divisibility by 12 implies divisibility by 3 and 4. Now if I give you number 14, I am asking you find divisibility test for 14. Number 14. How do we factorize number 14? If we start with 1, it is 1 into 14. But I asked you for this trick, ignore number itself and number 1 are factors. Ignore that fact. So we'll start with 2. 14 can be factorized as 2 multiplied by 7 or 7 multiplied by 2. Is there any other factor? 3 into something, 4 into something? No, I guess the factors are over. 14 can be factorized as 2 multiplied by 7. 2 and 7, do they have any common factor? No, 7 is odd number, 2 is even, so they do not have, in this case, 7 cannot be divided by 2, so 2 and 7 do not have any common factor. That means a number for divisibility test of 14, what you can say, a number which is divisible by 2 and 7 is divisible by 14. See, you discovered divisibility test for 14. 2 and 7. If a number is divisible, this and is important. It should be divisible by 2 and 7. It is not 2 or 7. It should be divisible by 2 and 7. So if it is divisible by 2 and 7, it will guarantee that it is divisible by 14, and vice versa. If you know a number is divisible by 14, then it implies that it is divisible by 2 and 7. Now let's take number 15. 1 into 15, let's ignore that. 2 into something, no, 15 is odd number, so 2 is not a factor. So we'll start with 3. 3 into 5. Then 4, no. Then again 5 into 3, so I guess factors are over. So 15 can be factorized as 3 into 5. 3 and 5. Do they have any common factor between them? No. That means a number which is divisible by 3 and 5 is also divisible by 15, and vice versa is also true. A number which is divisible by 3 and 5 is also divisible by 15. So what did you do just now? You discovered divisibility test for 15. So we already discovered divisibility test for 12, 14 and 15. What is test for 12? If a number is divisible by 3 and 4, for 14, 2 and 7, for 15, 3 and 5. Isn't it very easy? So now let's go back to that language which we discussed when we started this session. Trick is factorize a number in such a way that there is no common factor between the factors. Now you understood this language? Very easy? Very good. So now what we are going to do? As I promised, we are going to discover many divisibility tests on our own. Let's see how. Now you understand this. When I take any two adjacent numbers, what is adjacent numbers? 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, 19 and 20, 25 and 26, 30 and 31, they are all called adjacent numbers. That is, difference between them is 1. 4, 5, 6, 7, they are all adjacent pairs of numbers. So what we are going to do? We are going to observe these adjacent numbers. Let us observe them. Let us observe these pairs. If I start with 2, what is the next number? 3. This is one pair. Okay. If I start with 3, its next number is 4. If I start with 4, next number is 5. If I start with 6, next number is 7. They are all pairs of adjacent numbers. I have taken 4 pairs for example. Always remember that adjacent numbers do not have any common factor between them. 2 and 3 are adjacent, they will never have any common factor. 3 and 4 are adjacent, they will never have any common factor. 31 and 32 are adjacent, they will never have any common factor between them. Okay. So now what our rule says? Find factors which do not have any common factor. So 2 and 3 do not have any common factor. What is their product? If I multiply them, what is their product? Their product is 6. So 2 and 3 are such factors of 6 which do not have any common factor. Am I right? If I take this product, 3 into 4, 12. So 3 and 4 are such factors of 12 which do not have any common factor. 3 and 4, no common factor. Take this product, 20. So 4 and 5 are such factors of 20, 4 and 5, they do not have any common factor. 6 into 7, product is 42. So 6 and 7 are such factors of 42 which do not have any common factor between them. So what conclusion we can draw from these 4 examples? It is based on our trick only. A number which is divisible by 2 and 3 is divisible by 6. A number which is divisible by 3 and 4 will be divisible by 12. A number which is divisible by 4 and 5 will be divisible by 20. A number which is divisible by 6 and 7 will be divisible by 42. Now we can find many such adjacent pairs, infinite adjacent pairs, isn't it? If we take number 100, then 100 and 101, that is also one pair. So from that pair we can discover our own divisibility test. So we can discover infinite divisibility tests. Now let's see some practical examples. If I ask you, find divisibility test for 18. I am asking you, find divisibility test for 18. Then how will you start? You need to factorize 18. We are not going to start with 1. We are going to ignore it. We are going to start with 2. 18 is 2 into 9. 18 is 3 into 6. 18 is 4, 5, no. Then again it will be 6 into 3 and then this will be repeated. So that's all. We can factorize 18 as 2 into 9, 3 into 6. 2 and 9. Do they have any common factor? No. We can consider this as our pair which satisfies our trick. 3 and 6. Do they have any common factor? Yes, 3 itself is a common factor. 3 to the 6. So this pair we can't consider for our trick. 18 is equal to 2 multiplied by 9, and 2 and 9 do not have any common factor. That means what? A number if divisible by 2 and 9, then divisible by 18. See, you discovered your test. Did you have to by heart or memorize anything? No, you just factorized it. You saw it. There was no common factor. So you directly gave your divisibility test. Now let us confirm it. Whether it is true. I am taking one number. 16236. 16,236. I want to see whether it is divisible by 18. I want to confirm. What is our criteria? It should be divisible by 2 and 9. Do you remember divisibility test for 2 and 9? This is even number. This is even number. So definitely divisible by 2. Is it divisible by 9? Let's take the sum. 6 plus 3, 9. 9 plus 2, 11. 11 plus 6, 17. And plus 1, 18. 18 is divisible by 9. That means this number is divisible by 9 as well. It is divisible by 2 and 9, which means it is divisible by 18. Remember this, it is divisible by 18. Was it easy? But there are certain numbers which do not have the factors that satisfy our trick. Let's see what I mean by this. If I consider number 16, how do I factorize it? It is 2 into 8 and 4 into 4, no other factors. Both these pairs do not satisfy our trick. 2 is a factor of 8, 4 is a factor of 4. So 16 doesn't have any such factors which do not have any common factor. That means for 16 we are not able to find divisibility test using our trick. Same is for 27. 27 can be factorized only in one way, that is 3 into 9 or 9 into 3, same. 3 into 9. 3 is a factor of 9. That means for 27 also we cannot find divisibility test using our trick. But let's see few more numbers. 24. 24 can be factorized as 2 into 12, 3 into 8 and 4 into 6. If I consider this pair 2 into 12, 2 is a common factor between 2 and 12. So this pair not good for us. 3 and 8, they do not have any common factor, good for us. 4 and 6, their common factor is 2, so not good for us. So for 24, what will be divisibility test? A number which is divisible by 3 and 8 is divisible by 24, and if a number is divisible by 24, then it is definitely divisible by 3 and 8. One more example, number 36. I have already factorized it here. 2 into 18, 3 into 12, 4 into 9, 6 into 6. Consider all pairs one by one. 2 and 18, 2 is common factor, not good for us. 3 and 12, 3 is common factor, not good for us. 4 and 9, no common factor, take it. 6 and 6 again, not good for us. So that means what is divisibility test for 36? A number which is divisible by 4 and 9 is divisible by 36. A number, if it is divisible by 36, then definitely divisible by 4 and 9. Few more. 45. 3 into 15, 5 into 9. 3 into 15, not good for us because 3 is a factor of 15. 5 into 9, yes, satisfies our trick. That means if a number is divisible by 5 and 9, it is divisible by 45. If a number is divisible by 45, it is divisible by 5 and 9. I am sure the concept is very clear to you. So now let's go to an interesting part. You and me together, let's formulate divisibility tests. I am going to start with 2. 2 and 3. Do they have common factor? No. So any number divisible by 2 and 3 will be divisible by their product, that is 6. Any number divisible by 2 and 5 will be divisible by 10. 2 and 7 divisible by 14. 2 and 9 divisible by 18 and so on. 2 and 17. If a number is divisible by 2 and 17, it will be divisible by the product, that is 34. Because 34 has two factors, 2 and 17, which do not have any common factor. So all of these examples are satisfying our trick, and it will be and so on. So infinite. If I start with 3. 3 and 2, 6. 3 and 4, no common factor, 12. 3 and 5, no common factor, 15. Product is 15. So what conclusion do I get? A number which is divisible by 3 and 5 will be divisible by 15. Divisible by 3 and 7 will be divisible by 21 and so on. Divisible by 3 and 11, it will be divisible by 33. Just go on finding. Few more. If I start with say number 4. 4 and 3 divisible by 12. 4 and 5 will be divisible by 20. 4 and 7 divisible by 28. 4 and 9. So if a number is divisible by 4 and 9, it will be divisible by 36 and so on, infinite. If a number is divisible by 5 and 2, will be divisible by 10. 5 and 3, then 15. 5 and 4, then 20. 5 and 6, then 30. 5 and 7, then 35. Number divisible by 5 and 8, it will mean it is divisible by 40 and so on. And in all these cases, vice versa is also true. That means if a number is divisible by 15, it will be divisible by 5 and 3 also. So on your own, if you noticed that you discovered infinite divisibility test, and you can go on and on. You can choose any pairs and formulate divisibility tests. So as I had promised you in initial part of this lecture that you are going to create your own divisibility tests, that promise is fulfilled. So what I suggest, in comment box of this video, give the pairs that you have invented. Okay, that will give you an opportunity to understand this particular trick and also to practice it. In the test that we just formulated, I considered 2 and 3, 2 and 5, 2 and 7. Why did I skip here 4 and 6? 2 and 4, they have common factor 2. 2 and 6, they again have common factor 2. So I had to skip these numbers in between. I can take only those pairs which do not have any common factor. Here also, I tried 3 and 4, 3 and 5, but I couldn't try 3 and 6. I had to directly write 3 and 7. Why? Because 3 and 6 have common factor 3. Here also if you saw 4 and 3, 4 and 5, but 4 and 6 I couldn't take because 4 and 6 have common factor 2. Then 4 and 7, but 4 and 8 I couldn't consider because their common factor is 4. So you have to consider only those pairs which do not have any common factor. I think the topic is amply clear now. If you have missed any part, if you haven't understood certain part, what you can do is rerun this video and then try to understand. If you have any doubt, that also you can ask in the comment box. If you haven't subscribed to my channel yet, please do so. Maths in Minutes with Priya. Give your likes, give your comments, give your suggestions. I'm waiting for them. So bye for today and take care. Let's meet in our next video, in which I'm going to start with LCM and HCF. So be prepared with factorization. That is going to help you a lot. And please start by hearting tables. See you then.